A researcher wants to determine an interval estimate for the average weight of adult gorillas in pounds. She wants to be 90% certain that she's within 6.1 of the true average. From past studies, it's known that the standard deviation of the weights of adult gorillas is 11.7 pounds. What is the critical value that corresponds to the given level of confidence? All right, so to come up with a critical value based off of a level of confidence, we do the absolute value of the inverse norm of 1 minus that level of confidence divided by 2. So in this case, my level of confidence is 0.9, so I'll just go ahead and plug that in. Okay, so if I take 1 minus 0.9 divided by 2, that gives me 0.05. Now, if I go to plug that into inverse norm, second and distribution, come down to inverse norm, and some of you may see this menu, some of you might not. If you do see the menu, that's fine. Just put the 0.05 in for your area and leave the mean and standard deviation as I have them here, 0 and 1, so that you're working with the standard normal distribution. If you're not seeing this menu, then just type 0.05 into the function inverse norm and press enter. Either way, you should all come to the same value here and take the absolute value, round to 2 decimals, so 1.64. So what is the minimum sample size necessary to estimate the population mean? So a minimum sample size, we get that through the formula z sub c times sigma divided by the margin of error squared. So we just found z sub c. That's what we did in the previous step. Now we need to just read back through the problem, figure out what the standard deviation was. So it said here the standard deviation is 11.7 pounds. So 11.7. And she wants to be within 6.1 of the true average. So that means the margin of error is 6.1. Now we make sure to square that value. And in this case, you can use 1.64, or you can actually just hit multiply, and it's going to take the entire value to as many decimals as are sitting there. The nice thing about that is you're ensuring that you're getting the most accurate answer that you can. If you don't do that, if you just use the 1.64, that's fine as well. The computer is programmed to take both results as answers if they happen to be different. So we did that value times 11.7 divided by 6.1. And notice it's coming up negative because that was negative, but that's okay because here we're going to square. And then that results in 9.95. It says to round your integer up to the next integer. So we'll round up to